Hello everyone, I'm super excited here to introduce our work, Source-Free Object Detection by Learning to Overlook Domain Style. Let's start with our problem, Source-Free Object Detection. In real-world application, domain shift exists between the try set and the test set, resulting in a performance decay. Source-Free Object Detection aims to study how to mitigate domain shift in order to transfer knowledge from source domain to target domain. Suppose we have labeled source data and unlabeled target data, then we train a source model. So how to fit-tune the source model with the target data is significant. It should be noted that the source data is not available due to data privacy or data transmission. Next, let's pay attention to our idea. We propose a novel learning to overlook domain style strategy. The target image is enhanced to generate a still enhanced image. Then the two images are fed into teacher and student detectors to obtain detection results. Finally, overlooking of target domain style is achieved by directionally aligning from the student to the teacher. Next, we explain the details. Our method consists of two parts, still enhancement module and overlooking still module. Target image and still image are fed into a pre-trained encoder to extract features. Then we get the enhanced feature by replacing the mean and variance generated by two networks, F1 and F2. And the still enhanced image is generated into using it. We use the still consistency loss to train the networks F1 and F2. While the decoder is trained via the content consistency loss. Next, let's see how overlooking still module works. Target image and still enhanced image are fed into student and feature teacher respectively. Based on the obtained features and predictions, we achieve two directional elements from the perspective of image level and instance level. First, propose a geography-based class-wise instance-level alignment, taking the constant similarity of each instance as a vertex. We construct two geographies, one for student and another for teacher. Then we construct a class-wise geography matching matrix and force the student's geography to approximate the teacher's under the constraint of the matching matrix. Model achieves a two-way knowledge distillation. Due to the alignment between the student and the teacher has a direction from student to teacher. So the knowledge flows from the teacher to the student when updating student's parameters, making student overlook still. While the knowledge flows from student to teacher when updating teacher's parameters, making teacher overlook still. Final part is experiment. Method gains the MAT by 15.3% on Pascal toward color and achieves the state-of-the-art performance Cityscapes to forget Cityscapes. Next, let's have a look at the application study. By comparing the result of boxed-out Residuals, the effectiveness of still enhancement module is verified. While comparing source-only TIA and GCIA, the effectiveness of overlooking still module is verified. Final section is the validation of the learned ability to overlook target domain still. It's obvious that the trained model learns the ability to overlook target domain still by comparing the four columns. To learn more about this paper, welcome to our poster session 2.29b.